Go ahead, take it away.
Sure. So we all know Joel. He's going to be talking about breaking up with a bundle, and he works at GitHub. So take it away, Joel.
Thanks, Dan. Thank you guys for the incredibly warm welcome. Shirts are hilarious. That might be that is definitely the highlight of my life for a while. I thank you for having me. It's a very special group, and yeah, it's been a pretty rough couple of weeks. And I would say that one of the main sources of sanity for me is doing things that I loved and cared about before it all happened. So this is a big part of that. So it's cool to be back and sharing hopefully something interesting. So yeah, where to begin? So I always like a good spelunk. So let's start on Friday, October 19th, 2007 at 10:25 p.m. Pacific time. And this is when the founder of GitHub wrote the first commit of the github.com Ruby on Rails monolith. And less than an hour later, he committed the first style sheet to the GitHub code base. It was just a couple lines of CSS. Oh yeah, all these commits, Brooke, you don't want to read any of these messages, man. This commit had just one line of CSS, simple reset of padding and margins. That's how a lot of us wrote CSS back then. And then it followed with some hard-coded colors for the body, a background color, and a better text color, so it wasn't just black on white. And it had a little bit of styling for links, a little bit of hover behavior and whatnot. So with good times. A couple months later, we had 238 lines of CSS. A couple months later, we had an order of magnitude more CSS. This is right about when GitHub launched to the public, so we had around 2,400 lines of CSS in the code base. 5 months later, the CSS doubled again. For reference, this is what GitHub looked like at the time. I actually couldn't find a higher risk screenshot than this, and it looks like crap if it's bigger, but yeah, this is what GitHub looked like at the time. And since then, our CSS continued to grow another order of magnitude, eventually plateauing at, we'll just call it right in the neighborhood of 40,000 lines for the past 8 years. And looking at this graph, I'm really happy that trend did not continue. I can't imagine where we'd be if we had kept adding that much CSS to a product. So looking at this graph, you can see that things stabilized right around 2014 and 2015. So what happened? Well, we made a design system, and it was called Primer. And Primer is basically our tools for building user interfaces the GitHub way. And it's no coincidence that we open sourced that work that we had been working on for a year or two in early 2015, right at the stabilization in that graph. It basically kind of leveled off the amount of custom CSS we were adding to our code base. The problem is that we never finished the work. We never addressed those 40,000 lines of custom CSS that we had. And as you can see, they have stuck around until today. So that's what I'm going to talk about today. I'm going to talk about the problems we've had with our CSS architecture, some successes and failures in addressing them, mostly failures, almost entirely failures actually, and some lessons that inform our vision for the future of how we build UI at the company. So do I even introduce myself? I'm Joel. I live outside Boulder. As a Colorado resident, I'm required to show you a picture of me and my dog. This is me and Captain over on, I can tell you all this because you actually might have been there. This is in Grand Mesa, just above Palisade. It's a beautiful place to go hiking, and it's kind of still a little bit of a secret. It's not that crowded. It's really nice. But some of you know, I don't really live anywhere right now because our house burned down a little over a month ago in the wildfires, and it's been insanely difficult. But we are surrounded by our friends and family and colleagues and meetup friends, and it's keeping us above water. I will say that I now know more about insurance than I ever should, and when we do Q&A at the end, I'm also just happy to talk insurance. If you ever just want to learn about how you're probably underinsured on your homeowner's insurance, make sure that what am I telling everyone? Make sure that you could actually rebuild your house for what you're insured for, because it's probably not true. And that's kind of what we learned through this process. It would have been a lot easier if I had known to think about that. Oh yes, Rylan, yes. I swear, this is like my new thing in life is I'm just going to tell everyone this one fact, which is like, just ask a builder sometime. Ask a friend who's a contractor, how much would it cost to rebuild my house? And make sure that that number matches up with what your insurance company says, because our insurance company disagrees with the builder by about a few $100,000. So that's my life right now, is navigating that gap. Anyways, back to what I was talking about. So at GitHub, I work as a staff engineer on the design infrastructure team. We are a group of like probably 25 designers and engineers total, and we build and maintain that design system I talked about earlier. So what even is a design system? I will take this quote from the Nielsen Norman Group. It says, a design system is a set of standards to manage design at scale by reducing redundancy while creating a shared language and visual consistency across different pages and channels. So it really resonates me about this definition is the part about reducing redundancy for the sake of visual consistency. It really is just another way of saying that design systems are abstractions. They're literally just taking what we do as programmers and applying them in the design world. They take the things that we do many times, say rule of three, at least 3 or more times, and standardize them. But like most abstractions that we create, design systems are only effective if they're actually used. And that is a great segue into talking about the problems we have. So if we look back at our graph of custom CSS, there are still at least 40,000 lines of it in our monolith. That's 40,000. That's 40,000 places that we don't use our design system. So what I really feel about this is that custom CSS is ultimately the true measurement of how well my team is doing at the company. This custom CSS represents 40,000 ways that our team has fallen short, where our work could be used, but isn't. So you might be wondering, why am I bringing this up now? What makes 2022 different than the past 8 years? The reason is that our custom CSS has turned from technical debt into liability, like most technical debt, but this one is a pretty bad one. And one of the biggest problems we've found is that it's becoming really difficult to make changes to our CSS. And one kind of way to explain this is that if things stabilized around 2015, but a lot of things also stabilized at GitHub, namely our user interface. Like this is literally what a Node.js repository looked like in 2015. In 2016, we moved our tabs to the top. 2017, we changed the background color on the header. In 2018, we really hadn't done much. Same in 2019. And then in 2020, we shipped a facelift that basically just like made the repo page full width and did some cosmetic things to the sidebar. And things have really remained pretty similar since then. I mean, and honestly, I don't think this is totally a bad thing. I kind of love how much of a constant GitHub has been design-wise. Let us not forget that during all that process where things were pretty stable, GitHub was bought by Microsoft for like billions of dollars. So obviously we're doing something right. But this outward-facing stability has really glossed over the incredibly difficult work we've been doing beneath the surface. It reminds me of a metaphor about how ducks appear to just like float across the surface, but if you see what it looks like underwater, they're really just like kicking up a storm. So like while to the public, GitHub has been a really stable interface, it's been kind of madness maintaining it and refactoring it under the hood. So one example of this is when we ship dark mode. So when we ship dark mode, this was the culmination of 2 years of work by our design infrastructure team, like massive amounts of work. And at least in part of that was because we had to make changes to many of those lines of custom CSS to support changing the entire color palette on the fly with CSS variables. And honestly, that's probably the conference talk I should be working on. A lot of people have been asking about like the architecture and like how we did the whole process of that. But maybe that will be the 2023 one or the 2024 one. So this is what I mean by it being difficult to make changes efficiently. And what really hurts here is that we have many more ideas for improving the look and feel of GitHub, but we struggle with being able to justify the amount of effort it would take to accomplish those things, especially relative to the effort it might take at another company, perhaps one that has less technical debt. In a similar vein, it's also been difficult to make changes to our CSS safely. I often joke with people that we do Twitter-driven development, because there's really nothing like the sting of a good visual regression, especially when the only way you find out about it was when people start pinging people they know who work for GitHub on Twitter. In this case, this copy buttons icon disappeared whenever you clicked on it. And if you look above, in the line above that has been clicked on, the button wasn't even the right size in the first place. So we actually had two visual regressions here. So this is one of the many examples of bugs we've introduced while trying to clean up some of those 40,000 lines of custom CSS. And the root of the problem here is that bad design doesn't break CI. Visual regressions are really hard to test against, even with manual testing, with screenshot testing. And that's assuming you know which pages will be affected by the change you're making. And let me explain. So say I have a single styles.css file, pretty typical in Rails app, and I have one index.html file that uses that style sheet. If I change that style sheet, I just have to make sure that my index.html file still looks good in my app. I go to that page and I check it out. But what if there are 3 pages that use that same style sheet? What do I do then? What pages do I need to verify? Well, it depends on which pages use which rules from that style sheet. And that can be really hard to figure out. So what happens when there are dozens of pages that share the same bundle? Or in our case, if there are hundreds or thousands? These are like the kinds of things that like keep me up at night, really to this day. There's a real human cost to not be able to make these changes safely. If you make a change and don't know if it broke something, it's eventually going to wear you down. So those are some of the problems we've been facing. Now let's talk about some successes and failures in addressing them. So one of the greatest sources of comfort for me as I've worked on this really gnarly problem has been one of my favorite blog posts of all time by Jeff Atwood. It's from 2007, and it's called Falling into the Pit of Success. And in the post, Jeff describes how working in C++ is like walking along the edge of a bottomless pit. That's the problem with C++. It does a terrible job of protecting you from your own worst enemy, yourself. When you write code in C++, you are always circling the pit of despair, just one misstep away from plunging to your doom. This really struck a chord with me. CSS was my pit of failure, right? Like, yeah, Chris, PHP, same thing, pit of failure. But Jeff's article, you'll notice, was not called the pit of failure. It was called the pit of success. And he continues and says, if we design our applications properly, our users should be inexorably drawn into the pit of success. Some may take longer than others, but they should all get there eventually. And I realized that this is what I needed in our architecture. We need to make working on CSS at GitHub a pit of success, not a pit of failure. So over the past year, we've tried a variety of approaches. We've worked to better understand and communicate the problem through measurement. We've tried splitting up the bundle by functional area. We've experimented with different techniques around encapsulating our CSS. And we've looked at ways of diffing the computed styles for a DOM. So let's start with measurement. So I had a spidey sense about our technical debt when I was looking at this problem. My hunch was really kind of twofold. I thought we had a lot of technical debt and that it was continuing to increase despite our efforts to remediate it. But a feeling isn't enough to convince others to help, let alone my fairly non-technical manager, to understand the problem enough to give me and my team time to work on it. So this reminded me of a quote from Tony Haar that premature optimization is the root of all evil. But the way I like to think about that is optimization without an end goal is a fool's errand. At our scale, there's always something more to do. As you can imagine, that is a lot of technical debt. We're probably not going to get rid of all of it. There's always going to be more code to clean up when your code base is 15 years old. So how can we measure this problem so that we'd have something to optimize? And perhaps most importantly, know when we've made significant progress towards that goal, and maybe when we're even done. So we had to tell the story behind our 40,000 lines of custom CSS. So I nerd sniped my colleague, John, and said, hey, John, how do you think we could use Datadog to measure our CSS tech debt? And he went and came up with this absolutely glorious dashboard. So on every CI build on our master branch, he ran a whole bunch of scripts that analyzed our custom CSS and pushed the results up to this dashboard. And he gave us this like living, detailed view into the problem that really helps you observe the effectiveness of our design system in basically real time. We're deploying every 15 or 20 minutes. This is updated on every deploy. So let's look at some of the measurements. What I love about this dashboard is that it causes an emotional response to the problem at hand, much like these kind of days without an accident signs that you sometimes jokingly see in cartoons like The Simpsons and on some construction sites. And he does it with a single number. It's the number of lines of custom CSS added in the past week. I've seen this number in the hundreds before. And what's great is that this just helps us understand the current and present growth of the problem every time you check in on this dashboard. And John has found other ways to show the extent of our recent changes. In a similar vein, he set up this graph that shows where those lines were added. So for example, a bunch of custom CSS has been added around tooltips in the past week. That might be something to look into because someone is obviously trying to do new things with tooltips that our design system isn't doing for them. We used a similar measure to track where our CSS linters are being disabled. So we have these linters that all get flagged that someone has to basically opt out of. We also track the bigger picture, such as our most disabled linters overall. This helps us understand where the design system is overridden the most. The most common override in our case is spacing. So people are like hard coding pixel values instead of using our spacing scale. Perhaps we have some room to improve there. We also track violations by code ownership. So for this example, this graph shows that there are thousands of uses of custom CSS in our marketing pages. This might indicate the lack of a systems-driven approach for these designs at all. And in fact, this specific graph has led to us creating a new design system just for our marketing pages because it was so clear that the need was there. And sometimes it's as simple as just measuring the number of lines in files. So this graph shows how our settings and discussion styles are the largest. This might be simplistic, but it makes it easy to tell where our problem spots are. And I can tell you that this worked because just a few weeks after he made this dashboard, I was in a meeting and my manager pulled up this document she had made. And she had used John's graph in her planning document. So by measuring this problem, we made it visible to people who were not working on the problem. And by making it visible, the people who help us put plans into action by resourcing our projects help make it really actionable. So a lot of the work that follows comes from this impact we had by measuring the problem. So that's how we benefited from using measurement. Another kind of thing we worked on when working on this problem was trying to split up our bundle. And it really all started with this very, very damning graph. So in addition to being difficult to refactor, our large CSS bundle was having some really real performance implications. So if you look at a pull request page, only about 3% of our 40,000 line custom bundle was being used to render that page. It's about 400 kilobytes of CSS that the browser had to parse unnecessarily, which I should note, unlike JavaScript, CSS is a blocking asset, which means that the browser does not render the page until the CSS has been downloaded and parsed. So this was having a real effect on some of our paint metrics. What also was unfortunate is that because we had everything up in one bundle, we would break the cache in this bundle multiple times per day. So it's not like this would be a long-lived thing that users might download daily or weekly. They were downloading it multiple times a day. So they were seeing this performance impact pretty regularly. So if we go back to our diagram, instead of having a single bundle for our entire application, we figured we could replace it with a bundle of just the code that we needed for that area of the product. And this is actually the breakdown we tried. So you saw in those graphs earlier, we had a lot of marketing CSS. We split that out. We have We had a big custom file for settings and discussions. We split that out too. And what we did is we wrote a class method that we added to application controller that allowed you to declare which style sheet bundles should be loaded for all the actions that are on that controller. So this allowed us to, like I said, move our marketing specific styles to their own bundle and then only load that bundle on marketing pages. We did the same thing for settings as well. But we ran into some trouble with this as we tried to split out the custom CSS for our discussions feature. Going back to our diagram, let's just focus on the discussions part. This is, of course, quite the simplification of our actual application. There are actually about 50 templates in the discussions folder, many of them being partials. And those partials created a new problem. People started to reuse them. So for example, we completely redesigned the way we did reactions for discussions. So people would reference this partial, say in the template for showing a release. This is literally a bug that we had happen recently. We redesigned releases to use these new reactions. You actually couldn't react to releases before this. But this didn't render properly in some weird edge cases because the CSS we needed to do so was only in the bundle for discussions, not in the one for releases. This hurt our ability to reuse this view code across the application, since doing so required loading whatever bundle contained the custom CSS necessary to render that partial. So this was a really tricky one. There really wasn't an obvious answer to the problem. And quite frankly, at our scale, problems like this just start to seem more common than ever. Like Rails no longer has an answer for all of our needs. Stack Overflow becomes less useful, and it's kind of a lonely existence. So one way we approach this and this kind of class of problems is to look across the broader web ecosystem for inspiration. What are people doing outside of Rails for this problem? So these days, a lot of innovation, good or bad, is in the UI architecture space is happening in the React ecosystem. And honestly, I find it pretty incredible. There are a ton of smart people experimenting with new ways of handling the complexity of building large-scale web applications. So how are they handling this problem? So here's an example from the React implementation of our design system. We have a styled div with a position relative, and it sets its color and padding from our kind of what we call primitives, which are basically the core design tokens from our system around colors and spacing and whatnot. But what's interesting is that these styles are defined inside our React components, right with the template, instead of having some global CSS bundle or multiple bundles, as I was just showing. And then at render time, under the hood, a hash selector is generated for each of the styles and attached to the element. This architecture is called CSS in JS, and it has some really pretty desirable benefits. One of them is referred to as critical CSS. Critical CSS means that you're only serving the CSS needed to render a page. Said another way, if we were to go back to our performance scorecard for CSS coverage, it would be scoring 100% instead of 3%. The second is encapsulation. So in the context of CSS, this really just means having the confidence that a change you make will only affect what you intended to. So looking back at the examples from React, CSS and JS like architecturally guarantees that the CSS you write only affects the React component you're writing it for by generating these globally unique class names. They're total computer gibberish, but it does work. So all those things seem pretty great. How could we bring those into our Rails app? So we started with a proof of concept. We decided to try the CSS modules approach as we were already using post CSS for our asset compilation in our Rails app. As a side note, the CSS modules logo is maybe my favorite open source logo of all time. It's just so brilliant. So our test case was the author's graph on the repository pulse page. This is like a really dark corner of the GitHub code base. It uses some custom CSS that isn't used anywhere else in the app, but this was being included in our global bundle that was loaded on every page on github.com. So literally when you loaded a PR, you also loaded the CSS, like the however many lines of CSS to render this graph. So here, just for the sake of this example, is some quite simplified version of the styles. Basically, we have a graph selector, a graph SVG tiled selector, and then a graph bar rectangle selector. And this sets some styles that make the graph look like what you just saw. So the first thing we did through this post process is we took the class names and we appended a random hash. kind of like CSS and JS was. There's a transform you can do this in post CSS with. And then what we would do is instead of referencing the class name directly in our template, we would call a CSS method that would look up the original, you would take the original class name, and that method would return the hash version. And that would basically look at a JSON object that post CSS would generate with those mappings when it compiled our CSS. So what's great is with a little bit of tooling like that, we now had our encapsulated styles, just like the React folks. What about critical CSS? How could we ship this CSS that we've now generated only when it was needed? And that's where ViewComponent comes in. ViewComponent, as many of you guys know, is the framework we built at GitHub that I work on. And the basic idea of ViewComponent is let's take all the cool things from React and bring them into Rails and see how we can benefit from them in our architectures. So in the most basic form, ViewComponents are pairs of Ruby files in an associated template. You might have a graph component RB and a graph component HTML.erb. So all we did is we added a CSS file next to the existing component files with the same base name and a SCSS extension. And then what we did is we told post CSS to compile this file into its own bundle. So this is like you'd compile an application.css. We literally now have a graph component.css file. And here it literally is in production. This is in production, just shipped to staff right now. But basically we have this graph at the top, and you'll have to kind of surf around the screenshot a little bit with me, but there's a generated selector. In this case, it's this long VC repositories pulse authors graph component graph. We ended up just using the name of the Ruby class, kind of just like converted into a class name selector. And then you'll notice down here at the bottom, we have this link tag with this component specific bundle, which means that we can render this component many times on a page, but only fetch the styles once. Because if you return a link tag to the same asset 50 times, the browser will just fetch it once and not load it again. So that's our experience with CSS encapsulation so far. This work is still really experimental and it's only shipped internally. But we think there's an interesting future to this kind of approach. The other thing I should mention that I didn't have in my notes here is that this approach would not be possible if it weren't for HTTP2. So with HTTP2, gosh, that's a mouthful. You're able to have more concurrent requests at page load time without negatively affecting the user experience. So before HTTP2, I think our rule of thumb at GitHub was no more than 8 concurrent requests on page load. You roughly at least by an order of magnitude with HTTP2. So our theory is that, like, say we have 40 components on a page that have custom CSS, we're not going to hit that, 80 to 100 concurrent request threshold that would cause issues for our customers. Anyways, it'll be interesting to see where that approach goes. The next experiment I worked on this year was around style diffing. So earlier I shared about how we've been finding it difficult to make our CSS changes, with any amount of safety, and how it was really painful to learn about them on Twitter. The issue here is the nature of visual regressions. It can be really difficult to programmatically determine whether a code change will result in a visual change. And I will say, what does it say about our work that what the best solution for this right now is to literally take a screenshot before and after and compare the two? To me, it just means a lack of confidence in the underlying tooling that we have. But more simply, CSS is hard to test, at least effectively, because you really only know the result of your CSS code once you load the page in the browser. One of the most common solutions, like I said, is screenshot testing. Here is literally a marketing page from Percy that shows more or less how the tool works. They'll use a tool that screenshots the before and after for a code change, and then basically operates a visual diff on it and gives you a screenshot that you then have to review manually. You can see there's a green button in the top right that says that effectively is the approval button for this visual change. So one day I was working on yet another visual bug, and I was poking around the Chrome Devtools to view the computed styles for the element that was affected by this bug. And it clicked for me, we had the computed styles here. What if we could diff those computed styles for a particular element, and instead of a screenshot, we could basically use that as like how would I call it? Like an underlying data structure for the screenshot instead of literally using a ping. So I started by looking into the documentation for the Chrome Devtools protocol. And this is the programmatic way of interacting with the Chrome Devtools in like an automated fashion. And I found pretty quickly just what I was looking for. There's actually an API that gives you the computed styles for a node. Given a node ID, it returns this computed style object, which is an array of computed style properties. And here's what it looks like in action. So grab an element, in this case, just grab an H1 off the document, and then grab the computed styles. And you can see there's this giant object, but I won't show you all of it. But it basically has all those CSS properties and values that were in the console. So how can we write a test around this data? Luckily for us, a lot of the work was already done. There's a gem called Ferrum that wraps the Chrome DevTools protocol. It actually is, I think, one of the best ways of writing browser tests in general in Rails at this point. It basically wraps that protocol and makes it easy to work with in tests. And thanks to like a 10-line PR I wrote, it now has a computed styles API. So here's what it looks like to write a test. So first we load our page in the browser. We say, go to this route. In this case, this is the test case from the PR I wrote. We select a test node, in this case, literally hashtag test node, and we grab its computed style. And we expect the, I didn't highlight the last one. And then we'll expect the color to equal what is basically red. So if we inspect the styles here, there's a hash, just like we had in our DevTools output. This is the computed value for every possible CSS property on the element. It's like 200 possible properties. So like I said, we can go back into our test and we can assert against a lookup on that resulting hash. And now we have a test that literally just makes sure programmatically this element has red text. So we now have a visual regression test for computed CSS that doesn't involve taking screenshots, which I think is very cool, if nothing else. But this is for like one specific property. What about a more general purpose solution? This is where what I call style snapshots come in. I don't have a lot of time to explain this in detail, but effectively what I'm trying to build is VCR for styles. And here's what it looks like in practice. So it compares those two style hashes, like a snapshot and a new one, and nicely formats the changed values. So you can see that these detailed test failures basically allow us to automate more of the visual regression testing process that would previously be really manual. So this would say that like this node, in between one version of the snapshot and the other, the color attribute, which is text color, changed from, I think this is red to yellow or something like that. So that's how we're using style diffing to try and make changes more safely. What does this mean for the future? Even with everything I've shared so far, I can't say that we've really made enough progress. One of the problems, many of these problems I've mentioned ultimately remain unsolved, if not worse. You may not have noticed on our graph, but this includes January 1st of this year. So I've been talking about what we did for the past year, and our CSS amount of custom CSS hasn't really changed. It's really hard to look at this graph with how much work we put into this problem and wonder, maybe our efforts haven't been enough. These approaches I've shared, I think are pretty interesting, but are they even viable? One common thread to this work has been, these attempts in various forms to delete our custom CSS, to clean it up, refactor it. And even with plenty of time and resources, I can tell you we've had several engineers looking at this problem with me in various capacities. We've still fallen short. It's been really time consuming. It's been, costly. Even with these engineers, with their time, we haven't really made enough progress, which is to say that it hasn't been cost effective. I don't think that even GitHub could buy itself out of this problem. It's not sustainable. So where do we go from here? Our best answer has been to rewrite. So instead of trying to wrestle with our custom CSS, we are focusing on just rebuilding our UI kind of from scratch using our design system. And we've come a long way. We've extracted about 50 of our most common patterns, and we've open sourced them as Primer ViewComponents with a lot more along the way. And this is what we imagine the future of building Rails, of what building UI in Rails really needs to look like. We need to move away from writing custom, hard to maintain CSS This reminds me of one of my favorite memes about, these two O'Reilly books about JavaScript and JavaScript, the good parts. It makes me think that, what would it look like to bring that same mindset to how we work with CSS? There are a lot of potential solutions, and it might need more than one of them, might need a system of solutions. But I'm pretty confident that what we have today in the Rails stack isn't the best answer, at least at the scale we're working at. So what I hope we can do is to continue to learn from each other's experiences and from other approaches in the greater industry, because the truly great ideas in this space should not be conflated with the technologies they are implemented in. These ideas can transcend frameworks and even languages. And we're going to need the greatest ideas from wherever they come from if we're ever going to break up with our bundle. Thank you.
Woo!
Super great. Great work, Joel.
That's awesome.
Thanks, Ryan.
As per usual for the 4th year in a row. This is an impressive talk and just the preparation you put into these things. Especially to put what you've been doing for quite a long time is very challenging. Anybody have questions? I had this thought, like while you're talking about the computed styles, is like, this is like an AST for CSS or something, but it's not a one-to-oneer, but it's like a background door you found in to like compare instead of taking these screenshots, which is crazy.
Yeah, the thing that's so wild is that like until you load all the style sheets in the order we load them in, the behavior could be totally different. Like we've sometimes thrown in feature flags that just you can put people in them and not tell them, like staff, and it will just turn off random style sheets to see if people notice. Like we'll just randomly turn off like the global bundle on like the dashboard and just see if anyone notices. We'll just like turn it on for staff and see if we get any feedback.
Like internal Twitter, they're adding you in the internal Slack or something.
Exactly. Yeah.
Hey, Joel, I had a question.
Yeah.
So you said that the motivating factor behind this was just the liability of not being able to move quickly, and other than kind of rational thought, is there a reason to believe that using the design system will let you move more quickly? Like, has that been proven out anywhere?
I would say generally so. I mean, the fact that we haven't written any more custom CSS since we first introduced it is obviously good evidence. I'm trying to think what other evidence we really have. It's so hard to, because we don't like A/B test, like, hey team, go build something without Primer ViewComponents and build it versus build it with. Like they don't really have a choice at this point, and B, we haven't really done that kind of experiment. I can't even imagine what the product would be like without a system at this point. I don't know. I mean, this is why all the big companies are doing design systems work, because it's like a survival instinct kind of thing. And that's like, maybe that's a note I'll take, that I think that like, I view the problem for the company as existential, because any problem we have that our competition doesn't is a liability towards being defeated. So like, if our competition is using React and writing CSS and JS, and they don't have this whole class of problems, they're going to be able to build a user interface that is much more compelling. And that is, I think, a key strategic weakness for GitHub. Like, I think that if there's anything that a competitor would do, is they would provide a drastically more modern user interface, even though I don't think that's ultimately what we need. It would certainly be easy to distinguish yourself from our company because our UI practices are a little dated.
Cool, thanks.
Yeah.
Hey, Joel, little question on Ferrum, which is really cool, by the way. How is it? Are you wiring that up? Are you still using Capybara like with that? Or are you running that separately? Like maybe kind of delve into that a little bit more, like what your test setup is for that?
I honestly forget. I mean, Ferrum is in a group of gems, and I think that they all end up working together. Let me see if I can pull it up and I could tell you. It's like ferrum.rocks. It's a great domain name.
Yeah, I was
Maybe
trying to
not,
read
yeah.
it quickly when you brought it up, and I was just scanning because I don't recall coming across that before. So yeah.
Yeah, it's rubycdp.com is the group of tools. And Ruby CDP, if I can load their website, it's very slow for me right now. Where's the group of these? Yeah, there's Ferrum. What are the other ones? They all wrap each other. Oh, Cuprite. So Cuprite is the headless Chrome and Chromium driver for Capybara. So yeah, it uses Capybara under the hood. Yeah.
Okay. Thanks. Yeah.
Yeah. That's what we end up using for all of our, like, when we do browser tests now, we use the stack. Yeah.
Okay. Awesome.
We do very little of it. Do you write much in the way of system tests these days?
No, actually. Most things are kind of the classic feature tests, I guess, which I guess
They use browsers?
um
Or they controller tests?
no, that's actually using Capybara and browser. Yeah. So headless
Yeah.
browser in that case. Yep.
Yeah,
but
so it's a
just,
similar stack. Yeah.
yeah. Just lightweight feature tests. And then the rest is just request specs, right? Just hitting the API.
Yeah.
Yep.
Yeah, it's typical. I mean, we have almost none, which is also a wild thing. We had like a GitHub lore is that we had like a browser test suite, and it was just so unreliable and frustrating that someone just like made the decision to delete it and then never came back. It just like was not useful. I think that is actually one of the arguments for design systems. It's like you centralize all those decisions around design, and then when you reuse them, you don't actually need to retest your UI every time. It's just, I mean, it's like the same thing that if you were like, this is all I harp on with ViewComponents, right? Is like so many people in their templates do fundamental computer science things that we would never do anywhere else. Like tons of duplication, horrible or no abstractions. Like it's just like the Wild West. And that's what a design system ultimately aims to do, is to provide some method to that madness.
I sort of have a comment or question, I guess. So, I've been living, I do a lot of JavaScript as opposed to Ruby and whatnot. So I feel like, I wonder if like Ruby and or Rails doesn't, or even this presentation doesn't like show you the power of CSS modules and why they're so cool. Like, because they're scoped, to what you're at. Like, people know, right? In JavaScript, you'd import it in, and then you'd be like styles dot, and LSP would autocomplete the things you can use because that's the only things that are there. And it seems like, you know what I'm talking about, right? With the Ruby, it's like get the magic string. It's like, but it feels like a limitation just because there's so much magic in the framework, right? That it's hard to, maybe it's a silly nicety, but
Yeah, I mean, I think I know that there's some people that have been looking at, we're way behind a lot of the other big players in the industry on like the typing timeline. We're only just starting to look at it. But that's another thought, is that we could go all in and write style hashes. So to be clear, when you write CSS and JS, you're like literally just writing hashes, like hash data structures that have keys and values. So we could go all in and do that in a Ruby object. You could imagine you have a class method or even a constant that you define on a component that some sort of tool would look for all the children of a certain object and just like read the constants on each one and just build style sheets from that. Like it's all possible. I didn't mention this, but I built an implementation of CSS modules in Ruby that we shipped to production as part of this process. There was just no appetite at the company for maintaining a Ruby CSS build tool. So that's why we ended up with like the more traditional like post CSS approach, which seems to be like the way Rails is heading, which is like we'll look for a file in this place, but you don't need to tell us how it got there. Like you can use whatever build tool you want to drop an asset in this folder, and then we'll hash it in sprockets and deliver it for you. Yeah, I think that like for me, a lot of this work just kind of pointed out like Rails doesn't give you an answer for CSS that is beyond basically what the answer was 10 years ago. Like nothing has changed here. And I think there's no coincidence that like our CSS hasn't changed in 10 years. I do think, Tim, that CSS modules is ultimately the answer. The question is, how do we, once we prove it out internally, obviously we'd be more likely to try and upstream that stuff, but I don't know if that will ever happen.
Good luck.
Yeah. Has anyone else used any of the alternative, like the non-CSS bundle approach to writing styles? I assume, Tim, you're doing CSS and JS, right? Or are you doing just the bundle?
Yeah, we do CSS modules, or
Mhm.
I mean, sort of like what you're doing, just not in Rails.
Mhm.
Current place uses less, actually. Anyway, I spent my entire career voting CSS, so I don't really care.
Yeah, I think that one of the things that I think about is that one of the things we've been noticing is that like the deletability of CSS is really bad, like relative to other code. It's like the least deletable code you'll ever encounter. And I think that is what, I don't know, when you're writing Ruby and it's not good, that one of the things that allows you to like write Ruby that isn't perfect is that you can kind of be confident that you could refactor it later. But what we've been finding in practice with CSS is that like even changing it is really expensive. Like it's kind of like a append only kind of situation that like it's really hard to go back on. So like people who are used to like committing like an MVP to get something out on a deadline. Well, if there's CSS that they wrote on a deadline in an MVP fashion, the cost to remediate that MVP is very different than the cost to remediate some MVP Ruby, for example. And that ratio, this is great. I need to take more notes. That ratio is maybe the real root of the problem, is that like the cost to refactor is like, I would say an order of magnitude would maybe be a little bit dramatic, but it's so much higher than rewriting bad code in like any other language that I've dealt with. And you don't see that cost for 15 years or 10 years or whatever it's taken for us. And maybe that's why most people don't worry about it, because they don't know whether their app's going to be around in 10 years. I think that one of the really tricky parts of being an engineer at GitHub is that like, it ain't going anywhere. Whatever you work on, like you're going to have to live in that. You're going to sleep in that bed you made, to use the colloquial saying, way more so than, we have a longer tenure for engineers than most companies. And like pull requests are never going away. So like, whatever you did, you're probably going to have to come back and fix it. Which makes me look at these problems a lot differently. Like it'd be one thing if I was planning to be out of here in 2 years, but I'm not. And I want to be able to write CSS and not hate it.
Yeah, and just one clarification that I can't think of the verbiage anymore, right? The computed whatever, that's more like a just snapshot test as opposed to VCR, right? VCR is more like plugging it in. But maybe it doesn't. Maybe it doesn't come across much.
VCR records like a data structure, and then what you do is you make a new request and compares the data structures, right?
Yeah, I feel like those are a lot more are for like in a sense of like driving the test, like reusing them. Where snapshot tests more like what changed, what big ugly ass diff changed. But
yeah,
maybe it doesn't translate to the Rails world.
Hey Joel, how do you? This is more about that kind of mindset of a developer, because I've been in situations where I had to lie in my own bed and it was pretty unpleasant. So how, like, first of all, is that common across GitHub, or is it like in certain teams or in certain individuals? And then second of all, I guess we could stop recording too if you don't want to.
That's fine. That's fine.
And then second of all, like, is that something that you test for in interviews? Because that seems like a really interesting, like, do you have a 10-year timeline? View as a developer would be an interesting kind of thing to like shift interviews on.
That's a great question. I've never thought about it that way. I certainly, when I'm interviewing people and they ask, or like I talk about what I do at GitHub, that is something I definitely mention. You don't test for it. I will say that this is just like, were we talking about this earlier about how like, I don't think Agile really is meant for the environment we're in, at least in the way that I was taught it, because Agile is about delivering customer value in an efficient manner. But like, we're not trying to prove product market fit. Did I say that earlier? Yeah.
That was maybe before I got on. I don't know.
Yeah, I think that is kind of like the thing that I've kind of noticed is that like, I mean, just as I was saying that like Rails doesn't give you a solution to everything like this. What I also am seeing is that Agile doesn't give you a solution to everything. I mean, we all kind of know that, right? But I'm finding that I don't feel as confident that like the tools and processes we have for dealing with our current situation are good ones. Because like when we come to this meetup, we can all talk about our experience, current or past, at at a 50-person engineering org with a new. Dan, our org is 1,500 engineers probably. It's huge. And I feel like I just need to start reading a whole new corpus of books, because I don't feel like my experiences are really serving me super well in attacking these problems. That's kind of like the undertone of what I was just presented was, yeah, data intensive applications. It doesn't have CSS intensive applications though.
I know.
Yeah, I think that that's kind of the undertone, is that like this is one of the first times that I've like gone to like look at all my notes for a talk and been like, wow, like most of those things, like it just didn't work. Like here's a year of work with a lot of smart people that was quite expensive. And while we did come up with some cool things that did work well in some cases, like the fundamental problem didn't budge. But I didn't get fired for it, so. Thanks, Tim.